Okay, let's look at this problem. Two towns located directly across from each other operate a municipal wastewater treatment plant that are situated along the river. So there's a river, and there's two towns. The river is flowing, let's say it that way. The river flows is 50 million gallons per day. So the charge of the flow, 50 million gallon per day. Coliform count. What is coliform count? Okay. Coliform count is a test we do for drinking water. Okay. It indicates that there is a disease causing organisms like a pathogen. So, how we do it? We took a sample of the river water or the groundwater or any fresh water that before drinking, and we put the media. Look at this. This is the EPA certified test. The media will turn green, okay, if chloroform bacteria is present. If there is any pathogenic organisms, it will turn blue-green. Or it will remain clear yellow like this if coliform bacteria is absent. It's a test. It's simply a test to indicate if there is any pathogenic bacteria in water. Of course, here it's much easier than the other test because there is there is no special incubation equipment. Of course, and wait for 24 to 80 hours, 48 hours, and only the color change will indicate any pathogenic bacteria inside the sample. Okay, so coliform count are used as a measure of to determine a water ability to transmit disease to humans, pathogens. The coliform count in the river upstream of the two treatment plants, of course, every town has a treatment plant. They treat their wastewater before they dump it to the river. They treat their wastewater and they dump it to the river, okay? And of course, all of these, if there is organics, it will be advected with the flow of the river. So the coliform count in the river upstream of the two treatment plant is 3 chloroform. So here, the symbol of coliform count is 3 coliform per 100 ml. Town 1, let's just call this one Town 1 and Town 2. Town 1, the flow is 3 million gallons per day of wastewater. With coliform count 50, I'll just put COL per 100 ml to indicate coliform. I don't think I have space in this iPad. Town 2, the charge 10 million gallons per day. Coliform count is 20 coliform per 100 ml. Assume that the state, of course, the state of this town regulate the count of coliform and river water. The state requires that the downstream coliforms count not exceed 5 coliform per 100 ml. This is the regulation. If there is a violation of the 5 coliform per 100 ml, now they will regulate or try to put fine on the treatment plant of Town 1 or Town 2 or both towns. Is the water Is the state water quality standard being met downstream? This is downstream here. Let's say downstream, upstream, and the water is moving that way. The water is moving from upstream to downstream. Now let's check if that's true, if there is a violation or there is no violation. Let's look. Okay, first of all, we have to account for finding the concentration of coliform downstream equal. What is the concentration upstream? You should remember, we multiply Q times concentration. Remember when you multiply Q times C, this is meter cubic per day, for example, or milligram per day, times milligram per liter. Remember when we did this before? Liter, meter cube. This is 1,000, liter with liter, meter cube with meter cube. You end up with loading. So now we will we'll find the loading upstream, loading of town 1, loading of town 2, to find out the final concentration of chloroform after all this mixing between upstream, town 1 and town 2. So we have to put what is the first loading of chloroform. Remember the upstream, it's 3. I'm not going to put units because we know at the end we have to cancel out all these units. These units has to be consistent. 3 chloroform per 100 ml times 50. 50 million gallon per day plus. 5 chloroform of town 1 times 3 million gallon per day plus 20 chloroform per 100 ml times 10 million gallon per day, divided by what? Divided by the total flow rate. The way we do it here is by multiplying the concentration total times the flow total is equal concentration 1 Q1 plus concentration 2 Q2 plus concentration 3 Q3, and that's what we did, divided by the Q total. So what's the Q total? Let's see. 50 plus 3 plus 10. 50 plus 10, 60, 63. So you put here 63 million gallon per day. Now you could see that this is million gallon per day. It will cancel with this unit. This unit. It will cancel with this unit and this unit. So it will cancel out. You will end up with what final unit? Coliform per 100 ml. So if you finalize this answer, it will give you 7.9 coliform per 100 ml. Now, is there a violation? Well, let's look at the standard. The standard said if it's exceeding 5 chloroform per 100 ml, it is a violation. This is higher than 5. Which is the standard of the state. So the state water quality is not being met downstream. So there's a violation, and the state water quality, the state of the river is not met because there is a violation. The concentration of chloroform after the mixing is higher than the state regulation for chloroform count per 100 ml samples. Okay, let's look at question number B. If the state standard downstream is not met, the state has informed Town 1 that they must treat their sewage further so the downstream standard is met. Use a mass balance approach to show that the state request is invisible. Let's look at this. Let's do the mass balance and let's see if this is true. Okay, so we're going to use the same mass balance that we did here. Okay, so we'll do it like this. Q total, C total equals C1 Q1 plus C2 Q3 plus C2 Q2 C3 Q3. Okay, now we want the C total here to be equal to, remember the standard, this one has to be 5. 5, of course, 5 chloroform per 100 ml. What is the discharge total? We just mentioned that. 63. You could add up all the charges, 63 million gallon per day. I'm not putting units here because it will cancel out all of the charges because they have the same million gallon per day. And the concentration, they have the same concentration because they will be canceling out with each other. What does C1? Now, which one he want to change? He said he want to change Town 1. So Town 1, we want to make sure that this is further treatment. So is Town 1 only good to be treated by itself? Let's see. Let's find out, in order to meet the standard, what will be the concentration of chloroform of Town 1 in order to get only 5, in order only to have standardized and make it legal for both towns to dispose their wastewater after treatment. So Town 1 times, I'm going to put X times 3, X, which is the unknown, times 3 million gallon per day. What's Town 2? Oh, 3 is what? Oh, no. This is, the C1, Q1 is the total. So this is 50, times 3, We have to, 50 times 3. This is the total upstream of the water. Plus, now we go to Town 1. X times 3. 3 million gallon per day plus, and what's C3? 20 times 10. So these are concentration, but this is not concentration. Let's see, this is, so I'll do this one here, 50 and 3. 3 is chloroform, so this is chloroform, and this is million gallon per day, million gallon per day. Okay, nice. So now I should rearrange this and find out X. What will be the concentration of chloroform bacteria per 100 ml in order of Town number 1 in order to reach the state standard. So let's look at this one more time. 3 times 5, 50. X times 3, and 20 times 10. And this is 63, of course, times 5. Now, if you rearrange this and find for X, X would be equal to minus 12 chloroform You can see here that the combined chloroform level from the upstream flow and town 2, provided that you are forcing town 1 to have 0 coliform levels, it's impossible. Still, it's impossible to be done. You know why? Which means that town 1 has to reduce the level to -12, and this is impossible to be done. You have to work town 1 and town 2 together. Town 1 by itself, even, and because they can't go to -12, it's impossible. It's impossible for town 1 by itself to treat their wastewater without the help of town 2. So, town 1 sewage treatment to downstream, in order to be met, you can see that it's invisible. The state request is invisible. Okay? So it's impossible to do this. Impossible. For the state to force town 1 to treat their waste water. Okay? What will the state has to do? They have to go to town 2 too. Town 2 and tell them to treat their wastewater too. Because town 1, forcing town 1 by itself is not possible. Okay. Thank you very much.